Hello and good day, learners! Welcome to Tiradpas Network DepEd Candon City Teleskwela, kanlungan ng kaalaman tungo sa kahusayan at kaunlaran. Tara na! Welcome to another episode in Grade 9 Mathematics, Quarter 2, Week 3. I am Sir Ferdinand and I'll be your teacher for today's episode. Join me as we learn more about laws of exponents involving positive integral exponents to zero and negative exponents. This episode is anchored on our most essential learning competency, which is apply the laws involving positive integral exponents to zero and negative exponents. In today's episode, you are expected to: number 1, apply the laws involving positive integral exponents. Number 2, apply the laws involving zero and negative exponents. And number 3, evaluate expressions with positive, zero, and negative exponents. At the end of this episode, you will be able to answer this guide question: how do we apply the laws involving positive integral exponents, zero, and negative integral exponents? Last time, we have discussed about solving problems involving variation. Before we discuss our topic in this episode, let us check first your prior knowledge about exponents. Read each item carefully, then select the letter of your choice. You will have 5 seconds to answer. Are you ready? Let's get started. Number 1, what do you call n in the expression a raised to n? Letter A, base. Letter B, exponent. Letter C, factor. Or letter D, index? The correct answer is B, exponent. That's great. Number 2, what law of exponent is applied for any real number a and positive integers m and n? A raised to m times a raised to n is equal to a raised to m plus n. Is it A, product of powers, B, power of a product, C, power of a power, or D, power of a quotient? The correct answer is A, product of powers. Very good. Number 3, what law of exponent is applied for any real number a and positive integers m and n? The quantity a raised to m raised to n is equal to a raised to mn. Is it A, product of powers, B, power of a product, C, power of a power, or D, power of a quotient? The answer is C, power of a power. Very good. Number 4, what law of exponent is applied for all real numbers a and b and positive integer m? The quantity ab raised to m is equal to a raised to m, b raised to m. Is it A, product of powers, B, power of a product, C, power of a power, or D, power of a quotient? The correct answer is B, power of a product. Number 5, what law of exponent is applied For all integers m and n and any non-zero number a raised to m all over a raised to n is equal to a raised to m minus n. A, product of powers. B, power of a product. C, power of a power. Or D, power of a quotient. The correct answer is D, power of a quotient. Very good. Were you able to answer correctly? Very good. Now, let us discuss more about the topic. First, let us define positive integer exponents. If n is a positive integer, then a raised to n is equal to a times a times a up to times a of n factors, where a is the base and n is the exponent. The expression a raised to n is read as a to the nth power, or simply a to the nth. 2 raised to the third power means 2 times 2 times 2. 5 raised to the fourth power means 5 times 5 times 5 times 5. And x raised to the sixth power means x times x times x times x times x times x. Here are the 5 laws involving positive integral exponents, which are as follows. First, product of powers. Second, power of a power. Third, power of a product. Fourth, quotient of powers. And fifth, power of a quotient. Let us first discuss product of powers. Product of powers states that for any real number a and positive integers m and n, that is, a raised to m times a raised to n is equal to a raised to m plus n. The following examples show how product of powers is applied. Number 1. X raised to the third power times x raised to the second power is equal to x raised to 3 plus 2, and that is equal to x raised to the fifth power. Number 2. 5x raised to the fourth power times 4x raised to the second power is equal to 5 times 4x raised to 4 plus 2, and that is equal to 20x raised to the sixth power. Number 3. The quantity x raised to the third power, y raised to the second power times the quantity x, y raised to the fourth power is equal to the quantity x raised to the third power times x times y raised to the second power times y raised to the fourth power. That is x raised to 3 plus 1, y raised to 2 plus 4, and that is equal to x raised to the fourth power, y raised to the sixth power. Remember that in applying product of powers, simply multiply the numerical coefficients, copy the same base, then add the exponents. For power of a power, for any real number a and positive integers m and n, the quantity a raised to m raised to n is equal to a raised to mn. Examples for power of a power. Number 1. The quantity x raised to the third power raised to the second power is equal to x raised to 3 times 2 is equal to x raised to the sixth power. Number 2. The quantity a raised to the second power raised to the fifth power is equal to a raised to 2 times 5, and that is equal to a raised to 10. Number 3, the quantity y raised to the sixth power raised to the third power is equal to y raised to 6 times 3 is equal to y raised to the 18th power. Notice that we write the base and multiply the exponents. For power of product, for all real numbers a and b and positive integer m, that is, the quantity ab raised to m is equal to a raised to m, b raised to m. Here are examples of power of a product. Number 1, the quantity ab raised to the second power is equal to a raised to the second power times b raised to the second power is equal to a raised to the second power b raised to the second power. Number 2, the quantity 2x raised to the third power is equal to 2 raised to the third power times x raised to the third power is equal to 8x raised to the third power. Number 3, the quantity 3mn raised to the second power is equal to 3 raised to the second power times m raised to the second power times n raised to the second power is equal to 9m raised to the second power n raised to the second power. Remember to raise each factor inside the parentheses to the given power. For quotient of powers, for any positive integers m and n and any non-zero number a, that is a raised to m all over a raised to n is equal to a raised to m minus n. Here are examples for quotient of powers. Number 1, a raised to the fifth power all over a raised to the second power is equal to a raised to 5 minus 2, and that is equal to a raised to the third power. 12x raised to the fourth power, y raised to the fifth power, all over 3x raised to the second power, y raised to the third power is equal to 12 over 3 times x raised to 4 minus 2 times y raised to 5 minus 3. And that is equal to 4x raised to the second power, y raised to the second power. Therefore, in applying quotient of powers, divide or simplify the numerical coefficient first. Then, to divide the powers that have the same base, exponents are subtracted. Lastly, for power of a quotient, for any positive m and any non-zero number a and b, that is, the quantity a all over b raised to m is equal to a raised to m all over b raised to m. Examples. Number 1, the quantity x over y raised to the second power is equal to x raised to the second power, y raised to the second power. Number 2, the quantity 3x raised to the second power all over 2y raised to the third power raised to the third power is equal to the quantity 3x raised to the second power raised to the third power all over the quantity 2y raised to the third power raised to the third power. Then we have 3 raised to the third power x raised to 2 times 3 all over 2 raised to the third power y raised to 3 times 3. is equal to 27x raised to the 6th power all over 8y raised to the 9th power. Remember to raise all factors of both numerator and denominator to the given powers. The laws of exponents can also be extended to include zero and negative integers. Laws of exponents involving zero exponents. For any non-zero number a raised to 0 is equal to 1. Any number or expression raised to 0, the answer will always be equal to 1. May we have an example? 5 raised to 0 is equal to 1. 8x raised to the 2nd power y raised to 0 is equal to 8 times x raised to the 2nd power times y raised to 0. That is 8 times x raised to the 2nd power times 1 is equal to 8x raised to the 2nd power. Number 3, the quantity 4x raised to the 2nd power y raised to the 3rd power z raised to 0 is equal to 1. For any non-zero number a and any integer n, a raised to negative n is equal to 1 all over a raised to n. In evaluating expressions with zero and negative exponents, the following rules will be used. A raised to m all over a raised to n is equal to a raised to m minus n. That is, if m is greater than n and a is not equal to 0. A raised to m all over a raised to n is equal to a raised to 0 or 1. That is, if m is equal to n or a is not equal to 0. A raised to m all over a raised to n is equal to 1 all over a raised to n minus m. That is, if m is less than n and a is not equal to 0. Here are the examples. First, 6x raised to the 5th power all over 2x raised to the 2nd power is equal to 3x raised to 5 minus 2, and that is equal to 3x raised to the 3rd power. The exponent in the numerator is greater than the exponent of the denominator. Thus, we will have 3x raised to 5 minus 2. Therefore, the answer is 3x raised to the 3rd power. Second example, 10y raised to the 3rd power all over 5y raised to the 3rd power is equal to 2y raised to 0, and that is equal to 2. The exponent in the numerator is equal to the exponent of the denominator. Thus, we will have a 0 exponent. Therefore, the answer is 2 times 1, which is 2. Third example, 12a raised to the 2nd power all over 4a raised to the 6th power is equal to 3 all over a raised to 6 minus 2. That is equal to 3 all over a raised to the 4th power. The exponent in the numerator is less than the exponent of the denominator. Thus, we will have 3 all over a raised to 6 minus 2. Simplifying it further, then the answer is 3 all over a raised to the 4th power. Those are the different laws of exponents involving positive integral exponents to zero and negative exponents. In positive integral exponents, we have the following. product of powers, power of a power, power of a product, quotient of powers, and power of a quotient. In law of exponent involving zero, any non-zero number raised to zero, the value is 1. And in the law of exponent involving negative integers, for any non-zero number a and any integer n, a raised to negative n is equal to 1 all over a raised to n. To see if you have truly understood our lesson in this episode, let's have a short quiz. Get your paper and ball pen and simplify expressions with positive, zero, and negative exponents. Make sure to apply the different laws of exponents applied earlier. You have 5 seconds to answer each item. Number 1, 4y raised to the 4th power times 3y raised to the 5th power. The answer is 12y raised to the 9th power. That's correct. Number 2. The quantity 2pq raised to the 7th power r raised to the 3rd power raised to the 5th power. The answer is 32p raised to the 5th power, q raised to the 35th power, r raised to the 15th power. That's great. Number 3. 12x raised to the 8th power, y raised to the 5th power, all over 6x raised to the 2nd power, y raised to the 3rd power. The answer is 2x raised to the 6th power, y raised to the 2nd power. Correct? Number 4. The quantity 2 all over c raised to the 2nd power raised to 2. The answer is 4 all over c raised to the 4th power. Excellent. Number 5. The quantity a raised to the 2nd power, b raised to the 3rd power, raised to negative 1. The answer is 1 all over a raised to the 2nd power, b raised to the 3rd power. Perfect. Were you able to answer correctly the given items? Very good. Should you wish to know more about the topic, here are the references used in this episode. I hope you had fun learning today. Thank you very much for tuning in. Once again, I am Teacher Ferdinand. Stay safe and have a nice day. Bye!